Hey there! Let's talk about those crazy things out in space. Black holes. They've always made us wonder, right? Well, guess what? The James Webb Telescope is giving us a peek at these dark spots. I will tell you what's up with these huge, mysterious objects. If you want to keep up with space news, hit that subscribe button. And don't forget to like and share so everyone can join the fun. So, back in 1916, Albert Einstein came up with some ideas that pointed to black holes. He was the first to say they might exist, but people didn't start calling them black holes until much later. Some scientists thought he was right, but others weren't so sure. Then, in the late 1960s, some researchers were checking out the star system called Cygnus X-1, and they saw something odd. There was this super bright blue star shooting out X-rays. It was orbiting something dark and huge. Turns out, the X-rays weren't coming from the star, but were getting pulled toward this mysterious thing. This huge force was sucking everything in. That was the first real proof that black holes were actually a thing. And that was just the start of even wilder discoveries. After that, scientists started finding more and more black holes. They think there could be like 100 million of them just in our galaxy. The weird thing is, they're super hard to spot, so we don't know the exact number, but it could be way more, maybe millions. Physicists will tell you that black holes are these places where anything that gets too close gets crushed into a tiny spot. Imagine if you fell into one. They say you'd get stretched out super long, like spaghetti, before getting squished into nothing. Scary, huh? That's why everyone's so fascinated by them. Even though the closest black hole is super far away, like 500 light-years, people still wonder if one could ever suck up Earth. In 2021, scientists took the first actual picture of a black hole, the one way out in galaxy M87. They took pictures of it for days and found out it has 3 layers. Black holes aren't just empty holes, they're kind of complex. The first layer is the event horizon. Once something crosses that line, it's game over. It's either trapped there or pulled into the center. The center, called the singularity, is where all the gravity is. It's so strong that even light can't get out. To escape, you'd have to go faster than light, which is impossible. Remember, gravity works differently on Earth than in a black hole. Here, gravity keeps us from floating away, but a black hole's gravity is a whole different beast. If you cross that event horizon, you're done for. The singularity is where most of the black hole stuff is packed, and our rules of physics don't even work there. Inside, it's total chaos, and even time gets messed up. What's cool is that every black hole is different. Each one has its own gravity. Learning about one doesn't mean you know about them all. It's like a never-ending puzzle. The problem for scientists is that you can't study black holes like stars. Stars send out light and have stuff around them that we can see, but black holes are invisible. And you can't just send a probe into one because it would get destroyed instantly. So, we have to watch them from far away and guess what they're like based on how they affect things around them. Even with all these problems, scientists have some crazy ideas about what's inside. Some think black holes might be doorways to other places, like shortcuts between galaxies or even universes. Others think they could be glitches in a computer simulation, like in the Matrix. If we ever figure out how to travel faster than light, maybe black holes could be like space highways. But for now, these are just guesses. Could that singularity be more than just an empty spot? Could it be a wormhole to another galaxy? If that's true, it would change everything about how we travel in space. But then there are some scientists who don't even think black holes are real. This one team in Tokyo thinks they might just be holograms, like an illusion. Space is so huge and weird that anything's possible. So, even though it sounds crazy, maybe black holes are just fake. If that's true, then we're totally wrong about space and time. Maybe the universe is working in a way we can't even see, and black holes are just a trick of the light. No matter what, black holes are one of the most interesting things out there. They're powerful, mysterious, and might hold the secrets of the universe. As we get more information from telescopes like the James Webb, there's no telling what we'll learn, even if we've already made progress. How do they form? How do they mess with space? What are they really made of? Some scientists think they could even help us understand how everything is connected. As our technology gets better, we might finally figure out what black holes are all about. Until then, They're like a puzzle that keeps us guessing, inspiring us to keep looking deeper into space. Whether they're doorways to other worlds, weird spots in space, or just super strong gravity, black holes are sure to lead to some mind-blowing discoveries. As we keep exploring, we're building a better view of the universe and all the strange things in it. This adventure into black holes is just getting started, and who knows? We might find the answers to some of the biggest questions ever. The search goes on, and black holes will probably stay one of the biggest mysteries for a long time. Who knows what we'll find? Over the years, we will use better telescopes to study black holes and go deeper into these mysterious objects. We also have new chances to learn stuff. One of the main reasons black holes grab our attention is that basic rules don't apply there. Scientists are trying to figure out how black holes impact the space around them. They also wonder if they can provide with clues about dark matter and energy. Ultimately, we want to know about the origin of these black holes, their influence on galaxies, and their link to the Big Bang. New tools and researches will bring clarity over the years. With each new observation, we get closer to understanding the forces at play. Whether it's the bending of space-time, the jets of energy emitted, or their part in the development of galaxies.